Okay. So just like we had to figure out how to approximate means, when we have group data, we can do the same thing with standard deviations. So sometimes we don't have access to raw data, like we said before, and we're just given the frequency distribution. In this case, if we want to approximate a standard deviation, the first thing we're going to do is compute a midpoint for each class and approximate the mean of the frequency distribution. So we need midpoints and mean. Next, we're going to teach each class subtract the mean from the midpoint to obtain a midpoint minus the mean. And then the next step is we're going to square those. So we get those square deviations. And then we're going to multiply that frequency that midpoint minus the mean squared. And we're going to multiply that to the frequency because that means that's how many times that point showed up. So we're going to add the products of your mean slash midpoint, your midpoint slash mean, midpoint minus mean squared times frequency for all your classes. So if we want to do variance, then we're just going to divide it all by your big N, so your population size. If we want sample variance, then it's going to be little n minus 1, so your sample size minus 1. And then we take the square root if we want the standard deviation. So once again, with this data, we'd found all the midpoints already. So let's make a little room for a few things that we're going to need here. So like I said, we already had midpoint. We found this already. So if I just turn this into midpoints, we figured out the midpoint of this data was 25. And then we have 75, 125, 175, 225, and 275. So that's all my midpoints. Okay. So then what we need to figure out what that mean is. So we know if we want the mean, or our approximate mean, is that we're going to take each one of those midpoints, multiply it to its frequency. Oops. That was a midpoint of 125 times a frequency of 13, a midpoint of 175, and a frequency of 11. And then we have 225 and a frequency of 7. And then we have 225, oh, sorry, I did that one, 275 and a frequency of 4. And then we should divide by the sum of the frequencies, which we know is going to be 50. Okay, just a second, let me get that calculation. Okay, so we had done this before, so hopefully you have this recorded, but that mean was 137. Something is not lined up correctly. Oh, we can fix that here quickly. Okay, looks like we're just going to be a little out of alignment. For some reason it doesn't want to center again. There we go. Then what we're going to do is we're going to take those midpoints and then we're going to subtract that mean from each one of them. So we're going to do this one at a time. So if we did this one, it'd be 25 minus 137. So I'm not going to do every single one of these. So if we did this, we should end up with a negative 112. And then we do the next point, we do the 75 minus that mean of 137. Sorry, I was trying to get my calculator to. start working right now, so we can do all this. So that would be negative 162. We do this through each data point, and then we take that mean minus, or that midpoint minus the mean, and then we square it. So we take that negative 212 and we square it. And we get 12,544. And the same thing here, we take that negative 62 and square it. So remember, once you square everything, it should come out positive, but this is 3,844. So we'd keep doing that with the rest of that data. And then what I want to do is I want to take that midpoint minus the mean squared and then times to the frequency. So, sorry, the frequency. So our first one would be the 2,544. Frequency of that class that we're coming from would be 10. So multiply it to 10. We get 12,000. Oh no, we get 125,440 now. We would take that 3,844, multiply that by 5. And that will give me 19,202. And like I said, we should keep repeating this for all our data. But I just want to give you a few examples of that. So like I said, we need our midpoints minus our mean. So this would be all of them. And then we multiply, then we square it and multiply by its frequency. So the next thing we'd want to do is once we had that midpoint minus mean squared times the frequency, is we want to add that up. So we want the summation of midpoints minus mean squared times frequency. So if we did add that up, all of these numbers, what we would end up with is 292,800. So because what I was looking at is a population, if I want to end up with that standard deviation, I'm going to take that midpoint minus the mean squared times the frequency, that summation, and I divide by my sample size, so big N. So this would be 282,800 divided by 50. Get the answer for that very quickly. And that is going to be 5,856. And then if I want my standard deviation, I'm just going to do the square root of my 5,856. And I get around 76,000.52. 76,000. I'll get something completely different there. 76.52. Now, if instead we were treating that as sample data instead of population data, then what we would have is not just divide by 50, but by 50 minus 1. We divide by 50 minus 1. In that case, my variance for my sample would be 5,975.51020. If I take the square root of that, I get my standard deviation, which is 77.30242. Just remember, you have to be careful when you do standard deviations or variance that you make sure that what you have that you're calculating for either a sample or a mean, so you make sure that your data is matching the calculation. Now you can also do this with your TI-84. So what you would need to do, and this will do both your mean and your standard deviation, so you don't do not always have to do this by hand, but you need to make sure you have those midpoints and those frequencies. So if you did that same data with my midpoints and my frequencies, we'll go to my calculator here. Make sure you go in the list. A second, something's coming up on my screen. Enter my list. So you make sure you put in those midpoints. So my midpoints were 25, 75, 125, 175, 225, and 275. Then you go in the next list and you put in those frequencies. So the first one had a frequency of 10, then 5, 13, 11, 7, and 4. So ideally your lists end in the same place. So once again, we click on stats again. We go over to one variable statistics, hit enter, and we make sure that the frequency list, we put that L2 because that's where we listed those frequencies. And we hit calculate. So we see here, we get that mean of 173. And then if you did the sample, we get that 77.3, or like when I did it as a population instead, which was incorrect. But if you did it as a population instead, it's 76.5. You see all that same data right there. It's nice to know how to calculate by hand in case something goes, you need to do it, but also it tells you kind of what's going on. So knowing how your calculations are done can help you understand the situation a lot better than if you stick it in a calculator. So we're not trying to torture you by making you do it by hand or showing it to you. Just want you to understand what, the mechanics behind these calculations. So take a moment and try again with that distribution that we had about the presidents. So if you want to do this in your calculator, the first thing you need to do is find those midpoints again. So we have those midpoints and frequencies. Let me see here. I got my age of my presidents in midpoints now. We don't need this data. We just need those midpoints and those frequencies. And we're going to make an estimation of the standard deviation in the ages of presidents. And once back again, go back to the TI-84. We want to make sure we go to the list. Okay, enter. So we go up to the top, hit clear, enter, clear list one. So the top of list one, hover over it, clear, enter. Now we got that emptied. So we had 42.5. Oops, let's write that again. 42.5. Then we had 47.5. Then we had 52.5. Then we had 57.5. I'll get these in there here all right. 62.5. 65, or sorry, let's try that again. 67.5. Then we had 72.5, and then we had 75.5. And then the frequencies that went with that. The first one had a frequency of 2, second class had 7, then we had 13, 11, 7, 3, 1, and 1. So we hit statistics, move to one var stats, enter, list 1 should be here, frequency list is list 2, should be there. And we see, well, we got that mean that we calculated before. This is population data, definitely, because we had all our presidents. So we have our population mean estimate, which is 56.01. And then I had my sigma, my standard deviation estimate of 7.3. So leave it at 7.30. So on average, most of our presidents are about 56 when they become president. That's like the average. But like I said, we know we've had some presidents are much younger than this. We had 42 at a minimum, and I think 78 is the maximum. but on average, most of them vary by about 7.3 years from that, which is about true because the majority of them were in their 50s and 60s. So it's just trying to show you that this is where we expect to find the ages of presidents are going to be between like 50 and what would that be, like 65, something like that. And that is pretty much what we see in the data as well.